You know, in the time it takes you to watch this, a company's network is going to generate millions, literally millions of digital clues. Now, most of them totally harmless, but hidden somewhere in that massive digital haystack is a needle, a single malicious threat. So today, let's talk about how anyone can possibly find it. Think about it. Every single click, every login, every email you send, it all creates a digital footprint. We're living in a complete avalanche of data. So how on earth do security teams spot that one single snowflake that could trigger a catastrophe? To really get a sense of the scale here, just picture this. You're a detective, but your crime scene isn't a single room, it's an entire city, and every single speck of dust is a potential clue. That overwhelming feeling? Yeah, that's the daily reality for a security analyst. Okay, so before we can even talk about a solution, we really have to understand the scale of this problem. And it all starts with this relentless, nonstop flood of digital clues. You see, pretty much everything that happens on a network, an employee logging in, a server getting accessed, you visiting a website, it all creates this digital record called a log. It's like a digital footprint, a trail documenting every single activity. Now, these logs basically come in two main flavors. First, you've got your host-centric logs. These record events happening on a single device, like your laptop. And then you have network-centric logs, which track the conversation between all the different devices, like traffic flowing through a firewall. So what does this actually look like in the real world? Well, a log event could be something as simple as a user opening a file, a program starting up on a computer, someone trying to connect to a server, or even just your regular old web traffic. Each one is just a tiny individual piece of a much, much larger puzzle. All this data, it sounds great, doesn't it? I mean, more clues should make the job easier. But ironically, this is where the real problem begins. It's just incredibly easy to get completely lost in all the noise. So the first challenge is just the sheer number of sources. Your typical company has countless devices, laptops, servers, firewalls, all of them just generating logs constantly, all at the same time. This data isn't in one nice, neat pile. It's more like a digital confetti storm. And that, of course, leads directly to challenge number 2. There's no central place to look. Without some kind of dedicated system, an analyst would have to manually connect to each and every device one by one just to see its logs. I mean, talk about inefficient. It's a huge waste of time, especially when you're in the middle of a security incident. But here's the really dangerous part. A single log, all by itself, is pretty much meaningless. A user accessing a file, that's perfectly normal, right? But without context from other devices, you're just looking at a single puzzle piece, completely blind to the bigger picture. And, to make things even harder, every type of device speaks a different language. A log from a Windows machine looks completely different from a firewall log or a Linux server log. An analyst would have to be an expert in every single one of these formats, which is just not going to happen. So, here's the bottom line. Asking a human being to manually sift through this chaotic flood of data, it's like asking them to find one specific raindrop in the middle of a hurricane. It's not just difficult, it's practically impossible. But what if there was a way to automatically bring order to all of this chaos? Well, this is where the hero of our story enters the picture. It's called a SIEM, which stands for Security Information and Event Management. And to put it simply, it's a security solution that's designed to solve all the problems we just talked about. It collects, it standardizes, and it connects all those different logs to automatically spot the bad guys. So, how does this thing actually work? Well, a SIEM follows a really simple 4-step process. First step, collection. It just vacuums up all those scattered logs into one central place. Second, normalization. It acts like a universal translator, converting every log into one single, consistent language. Third, and this is the magic part, is correlation. It connects the dots between all the different events. And finally, alerting. When it finds a suspicious pattern, it sounds the alarm. Okay, so let's dive a little deeper into that third step. Correlation, because this is what makes a SIEM so incredibly powerful. This is how it actually connects the dots. Okay, let's just watch how an attack can unfold in only a few minutes. At 7:01 p.m., a user named Harris logs in from a brand new IP address. A minute later, he's accessing sensitive files. Then he runs a script, and finally, his computer connects to some unknown server out on the internet. Are you seeing the pattern here? You see, on their own, any one of these events could be totally harmless. A new IP address? Maybe he's traveling. Accessing files? It's probably part of his job. But when the SIEM correlates them, when it puts them all together in that really short time frame, the story changes completely. This pattern now looks like a classic case of stolen credentials being used for data theft. So, how does the SIEM know to flag that pattern? Well, it's not magic. It's actually just simple logic. Security analysts create these if-then rules. For example, if a user clears the event logs, which is a really common way to cover your tracks, then trigger an alert. Or if a command like whoami is run, then trigger another alert. It's all about spotting these known suspicious behaviors. Okay, so the SIEM has done its job. It shouted, "Hey, danger, I found something." So what happens next? Well, this is where the human analyst steps back in, moving from a digital alert to a real-world action. The very first thing an analyst has to do is investigate and figure out if the alert is a true positive, meaning it's a real threat, or if it's a false positive, which is just a false alarm. And this initial investigation is absolutely critical. And if it is a true positive, the analyst just springs into action. They'll do a deeper investigation, maybe contact the user to see if the activity was legitimate. Or, in a really serious case, they'll immediately isolate that infected computer from the network and block the attacker's IP address. And they might also tune the detection rule to make it a little smarter for next time. And this really just illustrates the whole point perfectly. A SIEM doesn't just collect data, it's a sense-making machine. It transforms millions of quiet, individual digital whispers into a single, loud, and actionable shout that a security team can finally hear and respond to. You know, SIEM technology really brought order to the digital chaos of the last decade. But our world is just getting bigger, faster, and way, way noisier. So the question becomes, what's the next frontier? How are we going to find the even quieter, more sophisticated threats of tomorrow? That right there, that's the multi-billion-dollar question the entire security world is racing to answer right now.